Hi, welcome to my channel, The Magic of Math, where we master math one video at a time. Today, our lesson is on adding rational numbers. You will do just that, add rational numbers. The question I'd like you thinking about today as I proceed through the lesson: how are adding rational numbers and adding integers similar? So first, we're going to talk about adding rational numbers with the same sign. So we have our same sign rule. Just as we did with our integers, we are going to find the absolute value of the rational numbers, add, and then use the common sign from the original problem. So it looks like this. We have square here because the integer chips were round, so I want to identify that these are rational numbers. So if I have a positive, add a positive, I get a larger positive. If I have a negative plus a negative, I get, and this is kind of different. It seems like a larger negative, but remember it's actually a smaller negative, but it's a larger absolute value. So even though the absolute value is increasing, but the negative is actually smaller. Remember, the larger the absolute value of a negative number, the smaller it is, the further left on our number line it goes. So again, just as when we added integers, if two values have the same sign, they're going to keep that sign. Add their absolute values, or you can say ignore the sign, add, and then go back and keep the sign of what both numbers were. So let's practice that. So I have rational numbers here because I have decimals and fractions. They are not integers, they are not whole numbers or opposites. And we're going to find the sum of each. So let's go through. We have two decimals, both negative. So I'm going to make myself a little note that my sum is going to be negative when I'm done adding. So now the absolute values are going to be positive. So we can ignore these signs and we're going to go ahead and add our decimals. So let's stack them, lining up my decimal point, and I'm going to add. 6 plus 2 is 8. Bring down the decimal point. 8 plus 7 is 15. So now 15 plus 8, but I made a special note, they were both negative, so my sum is negative 15.8. Now let's do the fractions. Again, these both have the same sign, they're both negative, so I'm going to make myself a note that my sum is going to be negative. I don't want to forget to add that back on when I'm done. So my first step is to find a common denominator, which is going to be 6. 3 times 2. 2 and 3 are both prime, so my least common denominator is going to be 3 times 2. So again, just as when we reviewed fractions, here's my fraction right here, 2/3, and I'm going to multiply both the numerator and denominator by 2. Whatever I do to one, I must do to the other. And here is my 1/2, and I'm going to multiply both the numerator and denominator by 3 to force a denominator of 6. So now let's do our multiplication. 2 times 2 is 4 over my common denominator of 6. 1 times 3 is 3, again my common denominator of 6. So now that I have the common denominator, I'm going to keep my denominator, add my numerators. 4 plus 3 is 7, so 7/6, and don't forget, we noted both of these values were negative, so my sum needs to be negative. And there you have it. Negative 7/6. Now it's your turn. I would like you to pause the video here, find the sum of each, and come back and hit play to check your work. Good luck. Welcome back. Let's check your work. So, same sign. I'm going to make a note that my sum is going to be negative. Now I'm ready to set up my addition problem. 16.34. I'm going to put the larger on top, 4.23, lining up my decimal point, and I'm going to add. 4 plus 3 is 7. 3 plus 2 is 5. Bring down the decimal point. 6 plus 4 is 10, so 0, and carry the 1. 1 plus 1 is 2. Don't forget that it is negative, and there you have your sum. Now let's check your work for the fraction. Both fractions are negative, so I'm going to make a note that my sum is going to be negative. I'm going to find a common denominator. 5 is prime, and 4 is 2 times 2, so they don't have any common factors. So my least common denominator is going to be 5 times 4, which is 20. So I'm going to change each by multiplying. Here's my fraction 1/5. To get 20, I'm going to multiply by 4 and multiply the numerator by 4. Here is my fraction, my second fraction, and I know I need to multiply by 5 to get the denominator to be 20, and I must do the same to the numerator. All right, we're ready to multiply. 4 times 1 is 4 over our denominator of 20. 7 times 5 is 35 over my denominator of 20. So now I'm going to keep the denominator of 20 and add my numerators. 4 plus 35 is 39 over 20. Not forgetting that it has to be negative. Negative 39/20. Now let's talk about adding integers with different signs. So our different signs rule, we're going to find the absolute value of the rational numbers. We're going to subtract the smaller from the larger, and then we're going to use the sign of the rational number that has the larger absolute value. Same as our integer rule when we had two different signs. So now let's look at this image. I have a smaller positive, a larger negative, remembering that it's not larger. A negative's never larger than a positive. We're talking about the absolute value. And then we're going to have a smaller negative. So think about that. This negative value is going to become smaller when I add something to it. So think about owing money and paying back some money, and you owe less money. And our second will be if I have a smaller negative absolute value and a larger positive, and I'm going to have a smaller positive. So think about that. Two different signs. Our sum is dictated by the larger absolute value. Let's practice. I have two different signs, and now I'm going to think about the absolute values. This is the larger absolute value. 13.2 is larger than 8.1. So I know that I'm identifying that my sum is going to be negative because our larger absolute value is negative. So I strongly encourage you to think about this before you start adding. Make a plan. So now I'm going to take my larger, and this helps me not only identify the sign of my sum, but it helps me determine what's going to go first. So I have 13.2, and I'm going to subtract 8.1 from 13.2. Now I'm ready to subtract. 2 subtract 1 is 1. Bring down your decimal point. 13 subtract 8 is 5. Remembering that my sum needed to be negative. All right, let's try two different signs with fractions. Once again, I'm going to look at the absolute values. 8/15 would be greater than 1/15, and it's negative. So I'm going to make a note that my sum is going to be negative, and now I'm ready to say that I'm subtracting. I already have a common denominator here, but I need to subtract the smaller from the larger. So that's going to be 8 subtract 1, all over 15, the common denominator. So that is 7 over 15, and reminding myself that my sum has to be negative, and there you have your answer. Your turn. I would like you to try the rule we just reviewed from our integer rule, but now it's our rational number rule. Go ahead and add, pause, come back when you're ready to check your work. Welcome back. Let's check your work. So I have two different signs. The absolute value of 4.5 is larger than the absolute value of 3.8. So your sum is going to be positive because 4.5 is positive. Now let's set up our subtraction problem. Seeing as I have two different signs, I'm going to take my larger and I'm going to subtract my smaller. Ready to subtract, but I cannot take 8 away from 5, so I have to borrow from the 4. And there's my 1. 15 subtract 8 is 7. Bring down my decimal point, and 3 subtract 3 is 0. Reminding myself that my answer is positive. Let's check your fraction. So before I can determine which has a larger absolute value, I need to get a common denominator because I cannot compare when they don't have the common denominator. So we're going to get a denominator of 10. 5 times 2. They're both prime. So if I multiply 5 by 2, I must multiply 8 by 2. Notice I've kept my negative here right now because I'm still not sure which is larger. 2 times 5 is 10. And if I multiply 2 by 5, I must multiply my numerator by 5. So let's do our multiplication. 8 times 2 is 16 over my 10 of a common denominator. And 3 times 5 is 15, again over my common denominator of 10. Now I'm ready to look and see which sign my sum will have. So the absolute value of 16/10 is greater than the absolute value of 15/10. So I know that my sum will be positive. So now that I've made note of what my sum is going to have for a sign, I can, remember, we're going to subtract the smaller absolute value from the larger, keeping our denominator, and 16 subtract 15 is 1, and my sum is positive, positive 1/10. So let's review our rules that we've learned today. If we are adding the same signs, if we have a positive added by a positive, we get a positive sum. If we have a negative adding a negative, then we have a negative sum. When I'm adding different signs, if I have an absolute value of a positive that is smaller than the absolute value of the negative, then it's going to equal a negative. And then if I have a smaller positive absolute value adding a larger positive absolute value, I'm going to have a positive sum. So please make sure those are in your notebook and reviewing your rules. Same sign, add and keep the sign. Different signs, subtract the smaller absolute value from the larger and take on the sign of the larger absolute value. Thanks for joining me today to review adding rational numbers, and I hope that it was a good review for you and you will practice, practice, practice. So thanks for joining me at the Magic of Math, where we master math one video at a time, and I hope you have a great day.